morning. So thanks for attending. This seminar is about the Plaza6G Plus project, or in other words, our take at experimentation-as-a-service in a telco cloud infrastructure. My name is Josep Manguez, and I'm head of the Services as Networks research unit of CTTC, and together with Sergio Barrachina, who is the leader of the project, Horacio Bleda, Omer Riaz, and Marc Carrascosa, we're going to explain you what we mean with that. But before entering into the details, let me start by thanking all these people. So this is the Plaza6G Plus team. So the pictures that you see here are the researchers of the team. So people that in one way or another contributed to build this framework that we're presenting today. But in addition to these people, where you see the picture, there is also the admin team of CTTC, which is working in the background and always helps in making the framework become reality in somehow indirect way. Right? So credit also go to them. So yeah, we're really thankful to all these people. And the one thing that you can deduce out of this slide is that the project, due to the amount of people that we devoted to this project, was strategic for us and for the whole CTTC, let's say, because it got the involvement of quite a remarkable number of people. Now, if we had to pick some key messages that we want you to take out of this seminar, this would be these three ones. So the first one is that Plaza6G and Plaza6G Plus, which were two twin projects, allowed us to develop this experimentation-as-a-service framework, which we understand one of its components is automated lifecycle management of experiments. So meaning that we put some smarts from the time you decide to create an experiment in our infrastructure. Whatever you do in the process in between, like changing configuration, sending traffic in one way or another, storing metrics, and so on, and then deletion of the experiment, right? So that's what we mean with experiment lifecycle management. So we put some smarts to make your life easy in a cloud-native 5G, 6G, or whatever generation technology you want to test. Now, the second item is probably the key one, because we put a lot of effort into it, which is usability. Usability, we understand it in different ways, in graphical user interface, programmatic APIs, or the use of agentic AI. Everything that we do is targeting to substantially reduce the amount of time that you devote to set up the experiment, because in fact the system does it for you. So that the goal is that you can focus exactly on your core business, right? So if you are a vertical application developer, you just focus on developing your application, and we put the network in the middle so that you test the performance of your application on top of this network. So usability is very easy to say, but very difficult to implement, right? So hopefully we'll convince you that we have managed it quite successfully during the presentation. And then the third message is that the underlying infrastructure on top of which we build this Plaza6G Plus framework is the Extreme Testbed. Extreme Testbed is a testbed that has been serving our research needs like for more than 20 years now. It has been adapting to the different generations of technologies and to the needs in terms of research that we have inside the group, but also with external partners in European projects or industrial contracts that we had. But now we are going a step beyond because up to now it was a more controlled environment, sort of internal and so on. And now we are putting it into service to external organizations also, right? So this shared infrastructure, sorry, will also serve the needs of external organizations. Now, if you want more information about the framework itself, you can visit our website, which is at the bottom of this slide. Now, to explain you everything we wanted to explain today, we structured the talk in these phases, in these stages. So the first one is I'm going to give you an overall context of the project, why it was generated. Then we're going to go a bit more into the details so that you fully understand what we're offering in terms of infrastructure. You'll see in action, we don't have time to explain you all the internals and everything that we have developed, but you'll see in action the agentic AI framework. But before that, you'll see some design decisions that the team made. And yeah, of course, you'll see a demo, and we will conclude later. Now let's move on to the introduction. So what's the context of this project? So Plaza6G Plus is a project that is part of the Único R&D framework, which is part of the Digital Transformation Ministry of the Spanish government, which in turn is funded by the Recovery, Transformation and Resilience Plan, which in turn is funded by Next Generation EU funds, right? So the mandate that we got from this ministry was to contribute to create a 6G ecosystem in Spain, where private and public organizations, so research and industrial research organizations, could collaborate and improve the knowledge and the outcomes and the innovations all over Spain in the field of 6G. Right? So that's what the mandate was. So for that reason, we decided to contribute in our own way by building Plaza6G and Plaza6G Plus to build this 6G experimentation and innovation hub. So we want parties to come and test and create synergies, right? By experimenting on top of our infrastructure. Now, the broader context are the two items that you see just below. So we've analyzed the test beds, the experimentation test beds on different technologies throughout the years. In fact, we've been part of some of these projects that tried to sell experimentation services, but they, in our opinion, they only achieved partial results. So meaning that in the end, there was always a step or multiple steps where the human was involved. So this completely stopped the process, and it was not so usable because you need to put your experiment in a queue, wait for the manager to answer, and so on. So we wanted to somehow get rid of that, right? So to fully automate experimentation in 6G. Now, the even broader context is that we, as a public organization, we've been receiving a lot of funding to generate all these nice experimentation frameworks that we have at CTDC, including Extreme Testbed. But now it's our turn on how to expose externally this infrastructure and to give them back to society, in this case, industry and external research organizations, right? Now, if you want to know more details, if you're curious, you can go to these two papers and more to come that explain a bit the design decisions that we took and how the system works and so on. Now, going a bit more into the details, but still high level. So we were talking about this Plaza6G and Plaza6G Plus project. So there was a precursor project called Plaza6G, which is represented by the gray rectangle in the middle. So the gray rectangle, the basic idea it tries to convey is that we have this underlying shared experimentation infrastructure, and we slice it for you. So we assign some resources end-to-end, the ones that you need for your experiment, and they are for you. And you can play inside this slice as you want. Then this slice can be built according to different axes. So you may want to have more or less control, or more or less realistic setups, let's say, right? So you may go from simulation to emulation, where some parts run in real devices and some others run through software, let's say, or more simulated through models. A controlled lab environment, where still you have real devices, but it's in a more controlled environment. You will see an example of what we mean later. Or you may want to go outdoors. So because we have an on-public network outdoors in the two buildings of that the CDC has in this campus. So that would make a realistic environment. Then, in addition to this basic framework that was there already for Plaza6G, we've been extending it substantially in Plaza6G Plus with infrastructure scaling. So meaning that we already had some basic network compute, and including GPUs in our infrastructure, but now we are substantially extending with Plaza6G Plus. To the right, you also have substantial extensions in terms of ORAN, hardware and software. We have nice features, as you will see, as Sergio will explain later. We also have this non-public network that we were mentioning, so this private network in the outdoor and also indoor. And we also acquired several different devices that allow us to test different use cases. Now, all this is handled through this end-to-end lifecycle management that we were talking before. But as I was mentioning, a lot of effort was put on usability. And usability came through these three threads that I was mentioning before. So to the left of this slide, you see a screenshot of the graphical user interface where you could manage and say what you want to do, what kind of machine you want to deploy, and so on. You also see, like, the vertical screenshot also is the agentic AI. You will see it in action later, but that's a screenshot. So you can interact with natural language with the system, not only asking what is out there in the framework, but also configuring experiments. And then, of course, you can also gather metrics, right? So usability is key. But in addition to the graphical user interface and the agentic AI, there's this third one, the programmatic API that we were mentioning before, whose idea is this one. So you, as a developer of a certain building block, you have your own CI/CD pipeline. And we want to be part of this CI/CD pipeline, right? So you do your own test, unit tests, and so on. You build whatever package you want to test, then you run your internal acceptance and integration test, and programmatically, you can deploy experiment with your app or whatever you are developing, and we run it on top of potentially a real network in our lab, right? Or in our outdoor setup, right? And once you're done with that and everything is successful, you can go to production. So that's the way we understand programmatic API. Now, going a bit more into the details, but still high level, we, in our system, like the internals, we have 4 layers. The underlying one is the one we already discussed, is the shared infrastructure. You will have more details later. Experiment modalities we also discussed. So, I mean, you can run simulations, emulation, more controlled environment. Even if it is over the air, you can still have certain control. You will see what we mean with that later. And also outdoors. Then the user layer at the top is the one we were discussing, graphical user interface, programmatic API, agentic AI. So it's the one that transforms the intent of the user, so what the user wants to do in terms of experimentation, to the language that the system understands, right? But the core layer, the brain, is the orchestration layer. So this orchestration layer has a scheduler, which is in fact the brain that maps the intent. So whatever comes from the top, what the user wants to do, it knows the underlying infrastructure that is available, and it does the mapping. So it's kind of a driver somehow of the infrastructure. So that translates what you want to do to how you do it, right? And deploys the experiment. And in addition to that, of course, there are other building blocks. And one that we would like to highlight is experiment repository. So experiment repository should be understood not only as the place where you store the metrics of your experiment, but the nice feature also is that you can store the configuration of your experiment because it's kind of infrastructure as code, right? So then you can keep track of everything, every single change in the configuration that you do, which is very good for reproducibility, right? And repeatability, and of course, it helps you in analyzing the results. And this was it for the context. And now I'll hand over to Sergio so that he continues with the key infrastructure as said and so on.
Okay, thanks, Giuseppe, and thanks everybody for attending, physically and remotely. So I will continue the talk explaining some of the key assets that we have been introducing in our lab. Then I will talk about the agentic AI framework, how is that we can provide natural language interaction to our platform. And then we will go through to the most interesting part, which is the live demo. So let's go with some of the key assets. The first one is that we understand Plaza as a data center. So you want a VM, we can provide the VM. You want 3 VMs, we can provide them. You want GPUs, you will have them, right? This is the first thing. So how do we manage all that? We have this complex set of servers, switches, storage, and so on. And all of this is controlled via OpenStack, which is a powerful tool for managing data centers, right? Just to put some numbers, this is our computing capabilities. So 3,000 plus cores. We have more than 50 servers. We have lots of memory. We have GPUs. We have 20 physical GPUs, but we also have the software for virtualizing them, so we can share them if needed, right? We have all the networking, connecting all these servers. So just to mention few highlights, we have links up to 200 gigabits. We have PTP switches, and we even have TSN switches for time-specific networks as well. Of course, a storage. We have a redundant Ceph cluster, so we keep 3 copies of everything, right? So we don't lose anything that might be of interest. And then the most particular thing is that we actually have XG equipment, right? So we're talking about 5G, 6G, O-RAN, and we are opening that to the public. How are we managing all this? Well, we have a blueprint which is based on infrastructure as code. Some of the tools we use are OpenTofu and Puppet, right? As for the muscle, we rely on KVM mostly, and well, other tools like NVIDIA CUDA. What else? In our recipe, we have Kubernetes and Docker, of course. And yeah, we need to monitor everything, and we rely, as most people do, in Grafana and Prometheus, right? So this is the first key asset. This is Extreme, and this is like a data center, but with access to a special XG RAN components, or equipment. Second key asset, which is also very, let's say, remarkable, it's our private 5G network. So this is the diagram. Essentially, we have 2 instances of private 5G that are here outdoors in this nice campus at CTTC, well, Parque Mediterráneo de Tecnología, right? And what does it mean? That apart from the core and all, let's say, all this backbone and let's say wiring through the UPF and all these kind of things, we also have the antennas. This is the remarkable part, and these are placed on top of our buildings, right? Just to provide some details, we are covering even the millimeter wave. So these are actually the bands that we are covering today, N40, N78, and N258, right? The third key asset, it's also a very remarkable product, I would say, which is very unique. It's a multi-anechoic chamber. And we say that this is unique because it provides with a setup where you can connect 4 isolated environments, right? Point to point. So if you want to connect 3 of these chambers, you just need to play with the attenuators, right? So imagine that you need to deploy some kind of experiment that needs to communicate 3 of these environments, 3 or 4. So you would play with the attenuations at 2 different bands, sub 6 GHz and also millimeter wave, and you can play with dynamic conditions. This is the scheme in more detail, but essentially we have a set of attenuators in both bands, and we have the antennas for doing so. This is very good for testing physical capabilities, but also other higher layer experiments, like, for instance, roaming or things like that. Right? Okay, let's go for the final one. This actually came specifically in Plaza6G Plus, which is, okay, how do we provide access to all-run equipment? Right? And for that, we have a combination of solutions. The first one is a solution by Bubble Run. So we have the MX PDK. This is for validating Open Run functions. We have the MX AI, so introducing machine learning as well for optimization. And the focus of that is not trying, but providing the capability of testing X apps and R apps that you as stakeholders could develop yourself. So if you need to test them, we're providing this solution. Another solution that we have comes from Keysight. So we have these 3 products, the USIM, RUSIM, and the rig test. I will not enter into much detail. These are quite relevant and famous products in the field. So we're also opening that for people that might need it. So I will move now to the GNTK framework. And as Josep was mentioning, the idea here was to try to reduce as much as possible the entry barrier for experimentation. So the first barrier that you have is infrastructure. So this is very expensive equipment and also hard to configure. And the second one could be the knowledge barrier, right? So maybe you are an expert on app development and you want to test your application of your 5G network, but you are not that much aware about how 5G works and how to set it up, right? So these were the 2 entry barriers that we wanted to overcome. This is why we wanted to go for an agent framework, and this is the overview of how it works. So before introducing these agents, Plaza worked like this, right? So we have a website and an API, and if any stakeholder or user wanted to interact, it could do so via the website, the graphical user interface, or through the API, right? Then the user would define the experiment or the intent, and that would be mapped to lower level characteristics by the mapper within the Plaza6G framework. The Plaza6G framework is complex and is composed of multiple elements, but here we are just drawing a couple of them, right? And at the end, the user asks for something, and we are mapping that into our infrastructure. So let's put the simplest example. The user says, I want a VM. So the Plaza6G framework is developing that in our infrastructure, in OpenStack, okay? Just as a reminder, our infrastructure is not only compute and network, but also this XG equipment that we're offering. Okay? Now, in order to make that even easier, right? Because sometimes it's hard to define a 5G network. How do you define that? No? All the links, all the components, and so on. So in order to make that even easier, we wanted to go for the agentic approach. And what we do now is we're introducing a chatbot to the website, right? For example, guide me on how to set up a 5G experiment. But at the same time, we are providing an agent, which is, let's say, the new brain, the new, let's say, interface between the natural language request and the Plaza6G framework. This agent, of course, is based on, well, it's supported by an LLM. And the interaction from our agent to the Plaza6G framework is done via an MCP server. This MCP server is exposing the capabilities of the Plaza6G framework to this third party, in this case to the agent, right? So in the MCP defines what can be done via tools, who can access, and so on and so forth. Right? So a little bit more detail. Essentially, Plaza is composed of the framework, but all these agentic components that run, let's say, before, in order to make this interface. So the approach is the user or the front end. If the user were to use this natural language thing, so the first thing that you would reach is the orchestration API, meaning the agent, right? And the agent can interact again with two things. The first one is the rack, right? So you could ask the agent, okay, what is Plaza6G, or is this feature supported? And this will go to a rack service that we have developed. And the other thing is, if the agent detects that some interaction is needed to the Plaza6G framework, we're going to do that via the MCP server, right? So the MCP server is like the door or the entry to the Plaza6G framework. Okay. There is an important thing that we wanted to tackle from the beginning, and this is a human design perspective, so we decided that, not the LLM, no? Say that we have a user that says, I want to deploy a 5G experiment. This is one type of request that we can get, but we can get an infinite number, right? We can get requests that do not have anything to do with Plaza6G, or requests that might be dangerous, and so on and so forth. So we need like a first layer for classifying this kind of request, no? And this is what we designed for that. So as I will explain in a couple of minutes in the demo, the first thing that this agent is doing is classifying the request. Right? So it can be something out of scope. It can be something that needs to go to the rack. It can be something that needs an action towards Plaza6G framework. Or it can be, the fourth one, is a special action which is representing the interaction with experiments that are already created in order to interact with them. I will show more about this later, right? But this dispatch action in orange, this would be, for example, list my experiments, create an experiment, delete my experiment, right? And the one on the bottom, the resolve action, is for interacting. So for instance, tell me about the logs of this particular module, or install this package in this VM, so on and so forth. Right? And we developed all this using the LangGraph, right, which is one of the most famous tools for agentic deployments. Okay, let's go to the live demo. I think we are good on time. So let me switch to the browser. Okay, and let me start simply showing how Plaza6G website looks like. So this is Plaza6G. Just a disclaimer, this is not the website in production, because the website in production has no access to our servers, right? This is something that we are working on in terms of security, but this same website instance is what will be published shortly to the production website, let's say, no? So if you go to the website, you will see the regular stuff. So we have a landing page, some videos here, with more details. We have the about. I mean, you can take the time to check it yourself. We have some blogs. We try to detail everything. Here we're putting our publications. We have a couple. We're expecting more. We have a new site, contacts, so on and so forth. So the regular stuff. And if we log in, let me use this wonderful user. Okay. When the user logs in, the website looks the same, but we have now 3 new features. So we can set up experiments. We can take a look to our current experiments, and we have even a shortcut for accessing the different resources directly from the website, right? For instance, you might want to access a remote VM or a Kubernetes or whatever. So you could do that here. I forgot to mention that here we have our chatbot, right? So we could ask something, what is Plaza6G, for instance? What is CTDC? Right, hopefully you can see it, more or less. So I will show you, in a couple of minutes, what is going on behind the curtains, let's say. But this question has been rerouted to the rack, and I will show that in a few minutes. But let's keep checking the website itself. So one thing we can do is to check our current experiments. Right now, we only have one that I was playing with the other day. Let's set a new one. We are now in a phase. We are able to deploy things both in LXD and in OpenStack. This is something, let's say, from the backend. This is an admin thing, but we want it to be transparent. So in this case, we're going to use OpenStack. And let's define our first experiment. Let's call it webinar over the air, right? And I will try to motivate now how difficult it is to set up, let's say, a 5G experiment, right? So you could do it one by one, defining, for instance, the different components. So let's say that you want to deploy an Open5Gs 5G core, right? So you would need to select how many VMs, maybe in Kubernetes, what are the resources of these VMs. So you could do it. You could go here for the virtual machines. You could select the resources and so on and so forth. You could do the same for Kubernetes. So you can do it. We're providing that. But you will need to define the network, the packages, the hardware, for instance, GNODBs. So from the very beginning, we realized that this was complex for the user. So this is not the way to go, right? How do we solve that? There are two possibilities. The first one is using the website, as we are doing, and we will rely on simple templates. These are recipes that we're providing as default. And the second option is via the chat, right? That's how I will show next. So let's define one via the website. Here we're providing templates. So let's say a user wants simply a VM with a simulator running. We could use this one, right? So here we can select a VM and the simulator. Maybe we want to run NS3, Omnet, or Commodore, which is a Wi-Fi simulator. So we could do that. And the user forgets about installations and so on and so forth. We could try to deploy a 5G network, let's say, pure with no over-the-air, right? We can do that here with this module. This is a template that we're providing. So you will need to select your UE, your GNODB, the core, if you want a data network or not, and even access to the internet. So in here, you can select from different types of 5G cores. You could select different type of GNODBs. Everything is software, right? Then we have this one, which is over the air, but in lab. So with a control environment. Here we are using the anechoic chamber. This is work in progress, but at some point we're going to offer the private 5G network here in the campus. Of course, at least at the beginning, this will not be automated. This will need interaction with a human, right? I think the reasons are obvious. And then if you want to access the packages of Open RAN solutions that we have, the same. You would access here, and we will provide the access for you. So let's define one now over the air. Let's pick this one. So this is what is going to happen. This is the anechoic chamber. In there, we have placed a real UE in one of the chambers and a real GNODB in another chamber. The user can select any 5G core. We are offering 3 of them, but yeah, you can select anyone, because if you want to, let's say, if you are deploying your own 5G core, good luck with that. But if you're doing so, you can simply ask for a VM and you deploy here your core if you like, right? But anyway, do we want a data network besides internet? Let's say yes. because maybe we want to try something in the edge or whatever. Let's pick OpenFabJS as 5G core. This is the G0B for this particular template. It's an Microsoft callbox. So let's leave it like that. And this is the font that we're using. We can play with the anechoic chamber attenuation, right? So in chamber A, we have the G0B. In chamber B, we have the UE. So let's put this link to 0. We don't want attenuation there. And we can put to the max values the rest, right? But if for some experiment you want a couple of G0Bs or a couple of UEs or whatever, you can play with attenuations. Let's save this. And we are ready to launch the experiment. And hopefully,
template.
yes.
And then if we want, for example, more, bits like, I don't know, 12 or like to reproduce the GPP scenario, then we need to go in another way, to install everything from.
You mean real G0Bs or emulated or?
Well, in the same way that you have here this template, but if we would want more links to simulate.
We are not providing the template yet, but it should be quite straightforward. Essentially, you will need more VMs and the network behind, so it will be possible. Yeah. Okay. Yeah. So we have an experiment VM prepared, which is this one. Okay. And in here, we will be providing the user access to the 5G core network, to the 5G core VM, to the data network VM, and to the real UE. Okay, so let's leave this working in the background. Now, let's switch to the other site, the other website. Here, hopefully,
we know it's creating a VM for the.
Right now, it's creating a couple of VMs, one for the 5G core, another for the data network. No, the UPF is here in the 5G core. This is a data network. Just if you don't want to go to the internet and you want to go to the edge or something. Okay. Yeah. So we could do the same via the chat. So what I'm going to type now here in this text box is the same as if I was typing from the website. But I'm going to use this debugging website that we have to show you what is happening in the backend. Okay. So we could ask for another experiment. For instance, I want to deploy a 5G network experiment, let's say with Euro SIM and free 5G core. So for instance, the experiment that is now being prepared is using OpenFabJS. Let's now use free 5G core. And in this case, we don't want over the air. We want everything virtualized. Okay. So we can say no need for over the air, whatever, right? Okay, so I will explain the system in a couple of minutes, but I just want to have another experiment in the background. Okay. So we decided that anytime that you want to interact with the platform, as of today, you have to go via a human in the loop. So we want confirmation by the user, right? So in this case, actually, I forgot to put the name to the experiment. So let's put a name. I don't know. Webinar free 5G core, right? Actually, this is the human in the loop. The first step was simply that I was forgetting a parameter. So it was about validation step. Now this is the human in the loop, and we are saying, well, the agent is saying, okay, your experiment will look like this. Let's confirm, and the experiment will be deployed in the background. So we can go back to our website, and we will see here another experiment. This is the new one that we have requested. Okay. Now, in this debugging platform, we have our agentic framework, and it consists of 4 things, let's say. we have the agent itself. The agent itself is this graph with, if I'm not wrong, I think there are 24 nodes. So our agent, if you want to see like this way, is 24 nodes. This is our agent. Okay. Then we have a service for the rack. We have an LLM running that our agent will use. And we have the MCP server, which is the entry for the Plaza6G framework. No? So let me show how it works, right? If you remember, the first thing that we needed to do was routing the type of request. Okay, there were four categories that we have. Let's see how they work. No, for instance, we can ask, what time is Football Club Barcelona playing this weekend, for instance, and hopefully this will be out of the scope, right? Because it has nothing to do with Plaza. And I'm not sure if you can see that, but here, if we go to the details, we would see that the router, this first node of the agent, is classifying the request as out of the scope. How is the agent doing that? Based on some context engineering and a call to the LLM, right? This is why we have this brain here. Okay. So we could also ask things about Plaza itself. So for instance, does Plaza6G include an anechoic chamber for among the assets available for research experiments? I don't know. You can ask whatever you like. And in principle, this should go to the rack, right? Yeah. So what happened here? The same. The first step is to classify the request. We call it conversation. This is a name that we put. Then we go to this node, and this node within the agent is handling the communication with the rack service, right? So we have a rack service, another process somewhere, which is waiting for this request. And then we are able to answer the user. Yes, Plaza6G includes an echo chamber, and so on and so forth, right? Now, let's go for the third type of actions. No, not actions, sorry. The third type of requests, which are actions. We have a bunch of them, but the simplest one is, please list my current experiments. And hopefully, we should see 3 experiments, right? Okay, we have here the experiments. And what happened now? Our router classifies the request as an action. Within actions, there are different types. And here, for the first time, we are seeing that since we are going to interact with the Plaza6G framework, we need to interact with the MCP server here, right? So we are using one of the tools exposed by the MCP server, and we're simply triggering that. We have an extra node at the end, which is for wrapping up the low-level communication between the agent and the MCP server to make it nicer for the user. So we're also handling memory, right? For instance, we can ask, list the experiments again, but with more detail. But just to show that our agent is taking care of the context, let's ask that, let's say, not explicitly. So list them again in more detail, right? This is what? List the experiments, no? We are not saying that. The agent is able to handle the context. So it will take a bit longer because now we ask for more details. So essentially, we are generating more tokens. So we have exactly the same response, but with more details. Okay. Okay. Let's move on to the fourth type of requests. And this request is for interacting with experiments that are already there, right? For instance, if you remember these over-the-air experiments, we have a couple of VMs. So let's check if they can access the internet, right? Sometimes we have problems with that, and this is something that you do, no? Ping 8888 just to check if it works. we could access each of the VMs and do that ourselves, or we can ask the chat to do it for ourselves now. So let's check internet connectivity from my VMs in experiment. I think it was webinar OTA. Yeah, webinar OTA. So our router should identify this request as something that needs interactions with an existing experiment, right? Yeah, sorry. But again, as I was mentioning, anytime that we want to interact with Plaza, we are introducing a human in the loop. This is a decision that we might remove at some point. So the agent is telling us, okay, you want to check internet connectivity. I think the best thing you can do, well, I will do it for you, but the best thing we can do is to ping Google DNS from both VMs. Do you agree? Yes, why not, right? So these commands will run in each of the VMs for ourselves, right? Let's see. Okay, so here we have the results. Yes, the pass, meaning we have internet connectivity for both VMs, and some logs if you want the logs, right? This is just a demo, but I'm sorry. Sorry, I'm with the path, and actually I have a mouse. Very good, Sergio. Okay. Yeah, so these logs right now are, let's say, minimal because it's just a ping, but if you were to ask for check what is the problem with this AMF or UPF or whatever, maybe you want a quick summary, but also you want to access the logs, no? What else? Yeah, let me show that you can actually, let me remove this. This is not showing, no, it's just for me.
That are available in these virtual machines, right?
Yes.
Okay.
Yeah. Maybe it will be clear like this. So I was checking the internet connectivity in this experiment, in these two VMs, right? But I could do the same with the other one. So we could access to the VMs. I'm saying VMs because I'm deploying VMs, but this could be bare metal or this could be Kubernetes. It's no problem. So let's access to one of the VMs, right? So here I'm within the UEVM, which in this case is URANSIM, right? So I can type whatever. I can type IPA, for instance, and I see the interfaces. So I could do that from myself, but I could simply use the chat. So I can do run the same, no? APA in VM. Sorry, what was the name? URAN UE. From my experiment webinar 356. Right, and this is pretty good because right now it's a human interacting, but at some point this could be any script or whatever, right? So yeah, essentially we will run the same command in the VM and we will get the same result, right? So here we have the logs of of this simple command, right? Let's do something a little bit tricky, and let me, yes.
Is in the virtual machine or independent?
No, it's the same. Yeah.
I mean, yeah, but if we do something to this chat, and then we would like that we intervene by ourselves, if we go to virtual machine, if we continue this whatever.
Yeah. Sure. So you can do, for instance, let me see. Run, I don't know, touch hello in right? So we're creating now a file. This is the command that will run, and in principle, we should see here. Yeah, we went to the home. Yeah, we are in home actually, I guess. Are we home? Yes. Yeah, so you see here the file. So it's the same. I mean, okay. No worries. Yeah, what I wanted to do, yeah. What I wanted to do now is something more challenging and maybe more useful. So you remember in our last experiment, we have a virtual UE and a 5G core and a data network and the G0B, right? Everything virtualized. So say that we want to test the connectivity between our UE and the data network for whatever reasons, right? So we might want to do that with an iPerf because we just want to check what is the maximum rate or whatever, right? So you could access each of the VMs, install everything and do it yourself, or you could use the chat again. No? So for instance, we could say run iPerf3 between, what was the name of this? You're running as client and DNN. I think it was the name. Sorry. DNN, right? Yes. DNN, a server in my experiment webinar 3.5G core. Right. What else? Yeah. So we want to check the iPerf, but from the 5G interface. This is the good one, not the control one, right? So our UE, our URN SIM UE, has a 5G interface in order to go through the G0B, right? So we can say make sure to use 5G interface USIM 2.0. Where else? In our VM. So of course, the more explicit you are, the better. But this is not only for Plaza, but for any LLM-based platform, right? So we can say do the iPerf, or let's say TCP, UDP, uplink only. Yeah, this is tricky. We cannot do it downlink because in 5G the data network does not know the IP of the UE, right? So this is the trick, right? Okay. So we have a new user request. It should be routed to the interactions, right? And I'm sorry, well, I was missing something.
It's a dot, but it needs a dash.
Dash.
CNN dash.
This one, no?
Yes. You can repeat, but
Yeah.
It's a problem.
You couldn't. I'm sorry. Wow, my glasses. What is the problem?
You want mine?
I'm sorry.
You know the point instead of that. Dot.
Yes, this is the problem. Maybe you can repeat all the command.
Okay, let me check. I'm sorry about that. Let me go here just in case. Where is the issue? Okay.
Yes.
Okay.
You have to remove the dot and put the
Okay. Okay, sorry about that. So now, let me go back again. We're trying to do an iPerf from the UE to the DNN, right? And the chat, well, the agent is providing for us a plan. And it's saying, okay, this is what I'm going to do. The first thing is to install iPerf in both VMs. Then I will run a server on the DNN. I will run the client on the UE. I will do that for TCP and UDP. Okay, so we could run this thing. It will take a while because installing iPerf would take, I don't know, maybe 1 or a couple of minutes. So let's this action run in the background. And let's explore the over-the-air experiment quite quickly. So in here, we're also providing some metrics that come by default. This could be parameterized by the user if needed, but these are the logs, well, the dashboards that we're providing for the 5G core in the over-the-air template, right? So if you see here, there is no traffic from the UE. Now let's generate some traffic just to see if it works, right? So here's our real UE. By the way, it's not working. The should not be. Sorry, there is some connectivity issue. Why is that? Let me see. And there is some glitch. Something. Yeah, sorry about that. There was some glitch. So this is a real UE. We are accessing it through Visor, right? And we can check for, I don't know, any videos. See. So I'm simply accessing YouTube, but the stakeholder, the user, could deploy here his own applications. And let's see, this is just an example. So if we go to Grafana, we now see that actually there is traffic running, no, via the UE. That's it. So we are providing here a way for the users to deploy any kind of applications or changing conditions or whatever, and remotely. Okay. Let me go back to our experiment for the iPerf, and it seems that it's done. It took a couple of minutes, and these are the results. So the agent installed iPerf from the DNN, iPerf from the UE, and started both iPerf sessions. Okay. As a final thing, what we could do is take advantage of this context, and we can say simply repeat the iPerf, repeat the UDP iPerf, for instance, this time with 100 megabits per second, right? Because by default, iPerf is using just 1 megabit, so we could do same. Right, so the agent will realize that the steps are similar, but now we have to append this bandwidth field here, right? So we can simply run it again, and this time will be much faster because iPerf is already installed. Okay. Yeah, sorry. Can remove this. Okay, this was on, and we have the results for the iPerf UDP, this time with 100 megabits per second. The last thing I will do for this demo is simply to delete everything. So we can go to the chat. And yes.
You say that here in the chat, like provide me some output. I don't know how we get a text by.
Yes.
How we do normally.
You could actually, I didn't mention that, but you could actually upload your scripts, right? So you can have your script running, and at the end or even during the script, you can access to it. You can say, make a summary of the logs generated by my script, and you will have it, right? So it's up to you how complex you want it. Yeah. Okay. So last thing for this demo, we can simply delete everything, right? Delete all my experiments. I mean, we could delete one by one, but what I wanted to show is that the agent is able to handle a request that need more than one action, right? So delete all my experiments. Yeah, so we have 3 experiments, confirm, and everything will be deleted. If we go here, there are no more experiments. right? So that was everything from the live demo. And as a final point, there is a very interesting use case that we are targeting, and we have some progress there, which is this one, as Josep was mentioning. We want to enable external testing through for CI/CD pipelines of the stakeholder, right? And we're working on that. So imagine that you have your repository. It can be an application or it can be anything, right? So this developer or these stakeholders commits some update in the repo, whatever, and you want to make sure that anytime you make a change in the repo, all the tests are passed, right? But there is a special kind of test that we are allowing with Plaza6G, which is a test that will not run in the runners of the stakeholder, but in Plaza6G. So for instance, imagine that you have been working on an application, you change something, and you want to make sure that this application will work in a 5G network. You don't have the 5G network. Well, most people don't have that, right? So we are providing that service. Okay, yeah, exactly. So network tests cannot run locally or in traditional runners. You need to target something. You need to target Plaza6G, right? So we have Plaza6G for that. And essentially, you would run your experiment, your script, or whatever. You will define when an experiment or a test passes. In this case, we wanted to accomplish that the end-to-end latency is below 20 milliseconds, the throughput is above 10 megabits per second, and the uplink throughput. These are mock values, right? But this is the idea. So we would do the experiment in Plaza6G. The CI/CD pipeline of the stakeholder will compare the values against certain criteria that he or she defines. And if the test passes, you can deploy that. Yeah, you will be sure that your last modification of the code is working in network level. Let's see. Okay, let me wrap it up with.
So for the last example, you need to share the GitLab, and then you define the external user has to define the test. No? Because you have the runners here in Plaza.
No, but the repo is from the user, so Plaza6G is not aware about this repo. The Plaza6G will just receive an API request with an experiment definition. Yeah. Okay. So just wrapping up. Sorry for the delay. So what is Plaza6G? Yeah. Okay.
Someone in GitLab does some commit, changing some, I don't know, maybe max scheduling or SDAP layer. And then this change, we have to check that supposedly is not affecting performance, it is going to work properly. So, but then this code somehow has to get installed and used in 5G Plaza.
Yes.
And then, okay, so we define this inside of this, okay, this script for.
Yeah, it's up to the user. Of course, in this phase, you could use our agent to make things simpler, but it's up to you, right? So we are working on that, but it could be, for instance, an iPerf is a very simple thing, but it could be, please run this script, but in a real 5G network. So the only thing that you need to do is to ask for an over-the-air experiment, and then run this at the UE or at the DNN, or maybe you are changing something in the core. Right, do that, and you make sure that you don't mess with, let's say, the networking side of any of your products.
Amazing.
Okay, thank you. Okay, yeah, so okay, Plaza6G and Plaza6G Plus allowed us to make our extreme testbed three things. The first thing is a data center. That's it. You want a GPU, we provide it. You want a cluster, we provide it. Then we have 5G and 6G equipment, which is open for the stakeholders and the users to use it. And the third leg is facilitating the experience of these users via this agentic framework. So this is Plaza6G and Plaza6G Plus. Why? Well, we have been discussing that through this seminar, but we wanted to provide on-demand services, right, for the industry, for the research, and so on, and to make things easier, right? Well, we have a fully functional system. Of course, it's been improved. There are lots of things to improve, right? But if you want to use it, you just simply contact us, and you will have your user, and that's it. And well, the roadmap, it's infinite, but of course, we're integrating a lot of hardware. The LLM and the agentic things, since they are not deterministic, but probabilistic, you can improve them all the time, right? So we will work on that. For instance, you might ask something and it might be routed to an out of scope for whatever reason. So these kind of things, we are tracking the logs and we're trying to make it better. And yeah, you have more information in plaza6g.eu. Sorry. Here we have more information, our publications, and some other social network stuff. And now, yeah, I think we are done. So thanks a lot, everybody, and for your questions.